In most of the web development interviews, you have to face questions about values and references. You have to face questions about JavaScript objects. Hey, this is Tapas. Welcome to tapaScript, where you learn things fundamentally and conceptually. Today, I am here again with another fundamental and conceptual video to share with you a lot of knowledge around JavaScript objects, references, and values. We'll be discussing things in and out to understand how references works, how object deal with it, what is object copy versus clone, and what kind of mistakes usually developers make in their code. We'll be going through a lot of examples, but most importantly, the entire video is created with some graphics so that you understand things, you get things very easily. So I hope you find this video really helpful, and if so, please like and share this video, and please subscribe to this channel so that you get notified every time I create such content which will be very useful for your programming career. So without any further delay, let's get started. I believe in understanding fundamental programming concepts before syntaxes. That's the reason we'll get started with understanding from data types, very fundamental, core fundamental things in JavaScript. So what are the basic JavaScript data types? The JavaScript data types are in 8 numbers. They are string, number, big int, boolean, undefined, null, symbol, and object. And among these, they are classified into 2 different sections. The first 7 are called primitive types, and the last one is a non-primitive type. Now, the question might come, what is the primitive type? What is non-primitive type? What is the difference between primitive and non-primitive? So primitive means they are the basic types. It means a string, a number are the very basic types, and non-primitive means a complex type that is built using the basic types. So if you know about object in JavaScript is a key value pair, where key can be any string and value can be any of these primitive types. Value can be a string, value can be a number, value can be a boolean, just like that. So to keep it simple, primitive are the basic fundamental data type in JavaScript. Non-primitive, which is object as an example, is a complex data type which is built using these primitive data types. That's it, primitive versus non-primitive. Now, as we have the idea about primitive versus non-primitive, the next idea we are going to take about value versus reference. So this is another thing. When we get started with programming, we very loosely use things like, okay, this is why value, this is why reference, but this is where I feel that most of the mistakes as a developer we do. We don't understand these concepts very fundamentally, so why we cannot catch things in code if sometimes it is going wrong. So let us understand the difference between value and reference. We now know primitive versus non-primitive. So in primitive, the value is handled by value type. In non-primitive, it is handled by reference type. What is value type and what is reference type? In case of value type, the value is handled by the actual data. Imagine there is a box and you want to assign some value to it, say value 10. So you will be keeping the value 10 directly inside this box. Imagine it in this way. So it means for any primitive that we have learned, be string, number, boolean, or whatever it is, the value that we assign to them, the data that we assign to them, it is the actual data that we are assigning to them. The actual data is what is getting assigned to them or will be stored in them. But in case of reference type, the thing is different. In case of reference type, it will hold a particular memory address on which the actual value is stored. Sounds little confusing. Okay, let me break it up. So for example, if there is a non-primitive thing that you are dealing with, for example, it's an object, and the value of the object will be stored somewhere in the memory, and that memory will have an unique address. So in this case, the address is x0s4. Now for reference type, the variable won't hold the actual value. Rather, it will hold that memory address in which the value is stored. So in this case, the variable will store the value x0s4, and in that memory address x0s4, the actual count 10 is stored. Think in this way. So that's how primitive and non-primitive handles their values in a value type way and the reference type way. I hope this is clear now. Now we will write some code about primitive things. We'll try to understand some use cases. Also, we'll see things visually how it gets represented before we get into understanding of reference type. So let's get started. I am using Chrome's debugger tool, the console. You can use any editor, but I feel this will be very easier for me to write code and instantly get the output. So let's get started with creating a variable called count and assigning it a value with 10. So what does it happen? See, it means that we are trying to assign a primitive type value, 10 is a number, a primitive type value, and trying to store that in a variable called count. As simple as that. So when we are trying to assign a value, equals is the operator through which we can do the assignment. Value get stored or get assigned to that particular variable. So it means wherever I use count, I will get this particular variable value back directly. Similarly, if I do let item equals to 20, it's the same case happen, that now there will be something gets created labeled as item, and the actual value 20 is getting assigned to that. So if we try to see this pictorially, it will look like this, that count 10. So there is a store gets created, is labeled as count, and the actual value 10 goes into it, and the value of the count is 10. If it is item equals to 20, so there is a store and it's labeled with item, the actual value 20 is in it, and the item value is 20. Quite simple, isn't it? Now let's make it little more tricky. How about we do count equals to item? Now what will be the count's value and what will be the item's value? We can see already, right? The count value is 20. Item value is also 20. Why is it so? So here the thing happening is something called pass by value. I think we heard it, this term a lot, pass by value. In pass by value, a new copy of the value will be passed. So it means when we do count equals to item, what was item's value? Direct value was 20. So a new copy of this value 20 will be passed to this count. What do you mean by new copy of this file? Because later point of time, if I change item, that is not going to change the value of the count. Okay. So right now I have assigned item to count, item's value was 20. So everything become 20. But later point of time, if I change item equals to 30, that is going to change only item's value. It is never going to change count's value. Count will remain 20. Okay. So every time you assign something, it is directly getting stored to this, and it doesn't have any reference to anywhere because we are handling a primitive value or primitive data type. Now see this pictorially. So in this case, if we do count equals to item, what happened? The 10 goes off, a new value 20 comes here, the count value becomes 20, but item doesn't change because count and item are two different things value wise. Their values are two different copies, not the same copy at all. Now if we do item equals to 30, we will be only changing item's value to 30 and item value will be 30. Count will be unchanged unless we assign something again to count like 50, then count will be 50 and here count value will be 50. So this is how pass by value, this is how value assignment works in JavaScript. The next thing that we are going to do, we are going to talk about non-primitive or the object type and going to see how the object assignments, object copy, all these things going to work. Let me introduce JavaScript object to you. So what is JavaScript object and what is the way that we can create an object? One straightforward way of creating an object would be using the object literal. Let's create an object called user and it can be created with a pair of curly braces. If you don't specify anything within it, you are creating an empty object. But if you need some property within the object, you will be creating them with key value pair. Key can be a string and the value can be any of those primitive data type, including string, number, boolean, whatever, right? That's when I told the primitive data types are the basic data types, and when you create a non-primitive thing like a complex thing, you will be using those primitive data types. So the user object's property value can be any of this non-primitive data type that we have seen. So in this case, we will create a string and we'll give the name as Sam. We have created user equals to an object. Now I'll query user and it gives me name equals to Sam. And this is the source of all the confusion. When I did count equals to 10 and printed count, I got 10. When I did user equals to an object, printed user, I got the object back. So it gives me a perception that the user variable is actually storing that object value, which is really not true. In this case, the value is handled by reference type. What does it mean? It means that the object name colon Sam gets stored somewhere in the memory, some location in the memory, and that location is having a unique address. Just like our house is having address, we have email address, something unique to identify a location. So the location in the memory will be identified by that address. The user variable will have the knowledge of that particular memory address. So whenever I am querying user, it will know on which memory address this particular object value is stored. So it will go to that memory address, query and get you back the value of this object. Now let's see this pictorially so that it makes more sense to you. Let's imagine this is our JavaScript memory space where there are a few memory locations already defined. If you can see those memories, and there is their memory address specified in some number. Now let's imagine there is one more memory location whose address is Q5ZZ, and in that location the name Sam, this particular value is being stored. Now when we assign let user equals to name Sam that object, it means that the user variable will now have this particular address, the reference address in it, that is Q5ZZ. It is never going to have the name Sam object value directly. So whenever we are querying, it knows that Q5ZZ is its memory address that it needs to query for or look up to. It does a lookup and it will find name Sam, this particular value, and fetch it. Let's take one more example. Now we will create one more object called employee, and we'll add a property called name and give a different value called Alex. So in this case also, we are creating another object called employee. That means we are creating another memory location. We are having address for that memory location, and the employee variable will have the reference to that particular memory location through that address. So pictorially seeing, we'll create another memory location. It will have an address. In that memory location, we have name Alex, and then the variable that we have created employee, which will have that address referenced. So whenever we query through this reference, it can fetch the name Alex. You got it? It's very simple. Now, one more thing that we're going to see. When we do let count equals to 10, let item equals to 20, and do count equals to item, we did this, right? What we did, the value, the freshly copied value was assigned to count, right? And when we changed the value of item later to 30, it never changed the value of count, right? This is how the primitive pass by value works, but pass by reference is a bit different. So we have this user object we know, and we have this employee object we know, right? Correct? Now what happened if I do user equals to employee? What exactly happened? If I do user equals to employee, so it means after that if I do user, I will see name Alex, which was actually employee. Now at a face value, you might feel that the things happening here is exactly same as it happened with primitive pass by value occurrences, but things are a bit different. First we'll understand pictorially and then come back here and we'll show that what difference it is and how big is this different, and this is may cause a number of bugs in your code. As we have done user equals to employee. User equals to employee means we are not assigning the value that's stored in employee's memory to user's memory. What is user holding? User holding Q5ZZ. What is employee holding? Employee holding X0S4. So if I do users equals to employee, it means now user and employee both will be holding X0S4, the reference value, because we are doing user equals to employee. The value of the right side will come to the value of the left side. When you do user equals to employee, employee's value is X0S4, that also get assigned to user. That means both employee and user now will have the value X0S4. Now if that happens, both employee and user has the value X0S4, that means from now onwards, user is going to point to X0S4, isn't it? So that's when you do user equals to employee, both are now pointing to the same memory location. And on that memory location, we have the value name Alex. So now user and employee pointing to the same memory location, which is having the value name Alex. Now the fun. What if I change employee? So I'll change employee dot name and I'll give this name as Tapas. So I have just changed employee's name. So if I print employee right now, I'll find name Tapas. But I have not touched user. If I print user, why it is coming name Tapas? Now it can be very well understood through this picture. What if you change name Tapas instead of Alex at the top? Both user and employee will be named Tapas, isn't it? Because they are pointing to the same references. This is where most of our developers get confused when they try to understand references. Because in references, they think about value. In references, you have to always think about the memory addresses. This picture, you have to imprint in your brain whenever objects coming into picture. Whenever objects variable equals to some object value, you should imagine right side there is no object value, there is a memory address. Behind that memory address, there is a value. So whenever you're doing this assignment on, only this memory address is getting assigned. The value is getting intact, untouched in that particular memory address, right? So now name equals to Alex become name equals to Tapas, ABCD, whatever it is going to impact both employee and user. This is what is called passing by reference. One question though, what will happen to name Sam? What will happen to Q5ZZ? What will happen to that particular memory location? Now here there is a concept of garbage collection. Not only in JavaScript, in many popular languages the garbage collection takes place wherever we deal with object and something we store in the memory. So if there is no strong references to that particular memory location, which we see there is no references, it means that nothing is referring to Q5ZZ. At least for other three at the bottom there is a dotted line reference. So that means something is referencing. We are not able to see it in this picture because we are not bothered about them. But Q5ZZ, nobody is referencing. So JavaScript garbage collection cycle is going to garbage collect them, free up that memory. Later point of time somebody else will be able to occupy that memory. Some other object can use that memory and do something with it. So I hope the references, garbage collection, all these topics, all these fundamentals are very clear to you right now. In JavaScript, whenever we are dealing with objects, copy is not the same as clone. Okay, so I have seen developers use the term copy and clone interchangeably. It's not exactly same. Copy means what we saw right now. We did user equals to employee. Both the references become same. Both are pointing to the same memory address. If we change the value in that memory address, going to impact both. That's purely copy. But when you do clone, when you want to do duplicate of an object, you mean that you want to create a new memory location. On that new memory location, there will be a value. Okay, so how do we create clone and how do you do cloning? Let us see that. Let's assume you have two cars. These two cars looks identical. We are talking about the scenario of copy. All right. Now this car's value, the property of the car, whatever the color, how many tires are there, how many headlights are there, how many doors are there, all these properties are stored as value somewhere in the memory locations. Let's say color and light, both are stored. Now in case of copy, both the objects will point to the same memory location, the one that we have just now seen. Okay, this is how is copy. But when we talk about clone, it's not the case. In this case, the individual memory locations will be created, though the value stored in that memory location may be exactly same, because that's why it is looking exactly to same car, but they are pointing to their own references. So it means in the left side car, if I change the color blue to green, only one car will change to blue to green, other one will still remain in blue. But in case of copy, where it was pointing to the same, if I change the color blue to green, both the cars are going to be green color car. So this is the fundamental, guys, between copy and clone. Please keep it in mind. Now we'll see things in code of how to clone an object, because we have already seen an example of copy using user and employee. So we are starting again with the user object we have, the employee object we had. User and employee both were pointing to the same memory location, holding the same value. So if we do whether user is equals to employee, in this case, we will find it true because they are pointing to the same reference. And please notice that we are comparing them with the strict equality operator, which is 3 equals. We are not doing them with 2 equals. So never use 2 equals, always use triple equals. So you're comparing them with user, triple equals, employee, we are finding they are exactly same. So it means it's a copy, C-O-P-Y, copy, so that you never forget. Now we are going to talk about clone. So let's take this employee object again, and we will be creating a clone of this particular employee object. How do we create it? To create a clone, there are multiple methods. We can use a method called object.assign, which I won't show here because in the future video, I want to teach you what are the different ways of creating object, and there I'll teach you object.assign. But right now I'm going to teach you how to clone an object using spread operator. How do you do it? So you have an employee object already. You take the employee object and just before the employee, you put 3 dot. This is how you spread and create a new instance of the employee object. And then you want to hold this instance in something which we call, say, clone employee equals to employee. Okay. Now, if I print clone employee, it will have the exact value of employee. But if I do clone employee equals employee, I will find it false, because though the value is same, now clone employee is pointing to a new memory location where the same value is stored. Employee was pointing to one memory location where the same value was stored. So now think about the card, the second case where we did the clone. Now two different objects are pointing to different memory location, and each of the memory location the same value name tapas is stored. Now if I go ahead and change employee dot name equals to Ravi and then print employee, I will see a name equals to Ravi. But if I print clone employee, I will still finding tapas. It won't change because they are pointing to two different references. So I hope this is clear that how to clone. The spread operator works great as long as you don't have any nested object. What is that? Let's take an example with this user where let user equals to an object which is having a key value pair name and tapas, and there is another property called address whose value is another object. So it's a nested object, an object within an object. Now if I use spread operator that we just now learned to create a clone, something like this, let cloned user equals to spread operator user is going to create a clone for sure. So if you have cloned user, you would find that this is the exactly same user clone. Now what if I change this user's name? Okay, I change user dot name equals to Ravi. Great. Now if I print user, I will find the name has got changed to Ravi, and I didn't touch the address, so address is as it is. Now if I print cloned user, I will still find it tapas because this is clone. Remember, it's not copy. They are pointing to two different references. All great. But there is a catch. The spread operator does a shallow copy. So it means it is not going to take care if there is a nested object. For nested object, it's still going to make a copy. A shallow copy is not going to make a clone. What does it mean? Now, for user, there is a street and there is a city as properties for address, right? So what I'm going to do, I am going to create the clone again so that I have a fresh clone. Now I am going to change user dot address dot street equals to a new value. Let's say 360 first cross. So we are creating a clone, right? So it means that still the user object's value and the cloned user object's value should be different just now as we have seen for name, but we won't see it because now we are actually referencing with the nested object. So for nested object, the clone doesn't work with spread operator. It will still be a shallow copy. So if you print user object now, you will see name tapas, address is 360. If you print cloned object now, cloned user now, you are seeing name tapas and you are seeing address is also 360. That's bad, right? So this is what the problem is with the shallow copying. But if you don't have any nested object, if you have just one level thing and your all property values are primitive values, there is no non-primitive value as a property value, you can very well use this spread operator to create clone. Now to clone something with the nested objects, it also calls deep cloning. You have to use another API that JavaScript provides. So for that, let's create the user object once more and let deep cloned user equals to, we are going to use our API called structured clone, and in that we are going to pass the object that we are going to clone. Okay, so now we have created something called deep user clone. So deep cloned user is exactly same as whatever we had created. Now let's do the same thing. Let's change user address street. So we'll do user address street equals to 360 first cross. Let's print user, the name is tapas, address is 360 first cross. Let's print deep cloned user, the name is tapas, address still remain 234 second cross. It didn't change to 360. So it's a pure clone, pure deep clone. So whenever you want to use deep clone, please use this particular API called structured clone. Whenever you want to use maybe a shallow copy, then or the first level clone, use the spread operator the way that we have showed you. There are many other libraries like Lodash and many other libraries which helps you to do deep cloning. But right now, if you look into structured clone, it's a global function and it's available on all the browsers, all the modern browsers. So if you're using modern browser, you can always use structured clone and can read more about it. The link is in the description of this video. So how was it, guys? Do you feel like dancing? Did you learn something new? Is it clear for you, like what is pass by value, pass by reference, what is object references, all these things? So if you enjoyed this video so far, why don't you like this video? Just press the like button. Why don't you share this video in your circle so that more people come to know about this video and more people get the benefit just like you did. And if you have not subscribed to my channel, why don't you subscribe? Because if you subscribe, it gives me a lot of motivation to create lot of good fundamental videos. And at the same time, if you subscribe and hit the bell button, you will get notification on the amazing content that I'm going to create in the future as well. So why wait? Like, share and subscribe. Thank you very much for watching. I'll come back again with another fundamental video very soon. Keep watching. Be a subscriber of tapaScript. Thank you.